Hello everybody. This lab is about finding the formula of a hydrate. So for that, you will be given an unknown sample of hydrate and your task is to figure out how many water molecules are attached per mole of the hydrate. And for doing that, what you need is a setup like that. You will have a crucible. These are crucible tongs. Make sure you hold crucible with the narrow side of the tong, and you will need a crucible lid, and you put it on. And first step here is to purify your crucible. For purifying your crucible, you need to turn on the burner. These are the strikers, and you turn on the gas, and you get a nice blue flame. If your flame is red, as you see here, adjust the air to make sure the flame is completely blue, because the red flame produces soot and it will deposit on your crucible. Now you want to reduce the flame enough so it is about, say, 2.5 to 3 inches, and it reaches the crucible nicely. If your flame is too low, then you won't be able to purify the crucible. So first thing is you heat up the crucible. I'm not sure if you can see the flame. The flame is clear. It is heating up the crucible really nice, and you don't have to cover it in this for finding the formula of hydrate. So it is up to you if you want to use the lid or not. But if you're using the lid, then you must put the lid here as well to purify it. So now we're going to purify our crucible. The idea is to burn any combustible impurities. You heat up for about 4 or 5 minutes, and then you turn off the burner, or you can move the burner aside. Make sure there is nothing else combustible there, and let the crucible cool. You would know that the crucible is cooled if you take your hand near you. Once you have purified the crucible, you do not want to touch it by hand, because the oils from your fingertips will be left on the crucible. Once you take your hand next to it and it has cooled enough, now you weigh the crucible on the balance and take the mass. But to be sure that all the combustible impurities have been removed from your crucible, you will need to repeat this procedure. Reheat the crucible for another 5 minutes or 2 to 3 minutes. Cool it down again, reweigh it till the mass is within very small range of difference. We call it as mass becoming constant. That means that you have burned off all the impurities. Now your empty crucible is ready to be used. Now what you do is, in this crucible, you put a sample of unknown hydrate. How much doesn't matter, maybe fill it about half the crucible. Take the mass of crucible and the hydrate. At this point, you are taking the mass of crucible and hydrate without heating it. Now you're going to strongly heat the hydrate sample again for 5 minutes to drive off all the water from it. After heating it up for 5 minutes, you again cool the crucible and hydrate and take its mass. Repeat the procedure to constant the mass to make sure all the water has been driven off. After you're done with the experiment, you will have 3 sets of data: mass of empty crucible, mass of crucible plus hydrate, and mass of crucible plus hydrate after you've driven off the water, so anhydrous compound. Using these 3, you can calculate the formula of a hydrate. A few things to consider here. Make sure your grip on the crucible is nice so you're not dropping the crucible, because if you drop and crack the crucible, you'll have to start the experiment all over again. Second thing, make sure your crucible has cooled enough. Why is this important, cooling part? Because if you put a hot crucible on the weighing scale, it can heat up the air around the weighing scale and puts an upward thrust, so the mass of crucible comes out to be lesser than the actual mass. And if in the second experiment you actually cool it enough, that will be error. So make sure that your crucible is cool before you take the mass. In this lab, there are many sources of error. So in terms of error analysis, I'm going to give you a few scenarios. Think about those and think about how will it impact the percent of hydrate in the formula. We will discuss these in class. The first scenario is, let's say you did not purify your crucible enough and you had some combustible impurities after you had purified the empty crucible. How would that impact the percent of hydrate in the compound? The second scenario is, unbeknownst to you, after you have put the hydrate in there and weighed it, some of the hydrate splattered out. You don't know that